Hey guys, welcome back. Today we are covering database keys, one of the most important topics in the entire database subject. We will cover all 6 types: super key, candidate key, primary key, alternate key, foreign key, and composite key. Real examples, clear analogies, zero confusion. Let us go. So first, what even is a key? A key is one or more columns in a table that can uniquely identify each row. Think of it like your Aadhaar number. Out of 1.4 billion people, it picks out exactly you. That uniqueness is what a key gives the database. Every key must be unique, help identify records, and connect tables together. Throughout this video we use one table, the student's table. Roll number, name, email, age, and class. Notice, roll number is completely unique, 101 to 105, no duplicates. Email is also unique, but age, multiple 18-year-olds. Class, 10A appears twice. Keep this table in mind. All examples come back to this. Type 1, super key. Definition: any set of one or more columns that can uniquely identify a row, even if that set has unnecessary extra columns. Roll number alone, unique, super key. Roll number and name together, still unique, but name is extra baggage, still a super key. Email alone, unique, super key. But name and age together, you could easily have two 18-year-old students named Rohan, not unique, not a super key. Every table has many super keys. We want the cleanest minimal ones. Type 2, candidate key. A minimal super key, meaning you cannot remove even one column and still keep uniqueness. Roll number alone, cannot remove it and still be unique, minimal, candidate key. Email alone, same thing, candidate key. But roll number and name together? Remove name, roll number alone still works. Not minimal, just a regular super key. Analogy: school election. Multiple students qualify to be president. They are all candidates. We have not voted yet. Before primary key, let me show you the hierarchy as nested boxes. Outermost, super key, all possible unique combinations. Inside that, candidate key, only the minimal ones. Inside that, primary key, the one we choose. The candidate keys we did not choose sit between candidate and primary, those become alternate keys. So, super is the biggest set, candidate is a subset, primary is one specific pick. Type 3, primary key. The most important one. The primary key is the one candidate key we officially designate as the unique identifier for every row. 4 rules. No duplicates. Every value must be different. No nulls. Every row must have a value. Minimal. Only the columns we need. And stable. It should not change over time. That last point is crucial. Avoid using emails as PK because they can change tomorrow. Here is our students table with primary key applied. Roll number highlighted is our primary key. Each roll number is unique. No value is null. And we chose roll number over email because roll number never changes. A student can update their email tomorrow. If that was our primary key, all connections to other tables would break. Roll number stays assigned to that student forever. Stable choice. Type 4, alternate key. We had 2 candidate keys, roll number and email. We picked roll number as primary key. So what happens to email? Email becomes the alternate key. Definition: any candidate key not chosen is primary key. Still unique, still useful, just not the official one. Analogy: class election, multiple candidates qualify. One wins as president. The rest who also qualified are the alternates. Email is still useful. Students can log in using email even though roll number is the primary key. Type 5, foreign key. This is what makes it a relational database. Definition: a column in one table that references the primary key of another table. Creates a relationship. Analogy: your college ID card has your roll number printed on it. That roll number exists in the main student's register. Your card is referencing the register. That is a foreign key. The database enforces this. You cannot reference a student that does not exist. This is called referential integrity. Let me show you exactly how two tables link. Left side, students table, the parent. Roll number is the primary key. Right side, marks table, the child. Roll number here is a foreign key. Roll number 101 appears twice in marks, once for maths and once for science. One student, many marks. That is the many-to-one relationship. Now what if someone tries to add roll number 999 to marks? 999 does not exist in students. Database rejects it. That is referential integrity. Type 6, composite key. A key made of two or more columns that together uniquely identify a row. No single column alone is enough. Analogy: career address, city alone is not unique. Street alone is not unique. But city plus street plus house number together gives exactly one location. In our order items table, order ID alone repeats, product ID alone repeats. But order ID plus product ID together, every combination is unique. That is the composite key. Now let us compare all 6 keys side by side. Super key, one or more columns, unique, nulls allowed, many per table. Candidate key, minimal, unique, no nulls. Primary key, chosen candidate, unique, absolutely no nulls, only one per table, remember that, only one. Alternate key, unused candidates, unique, no nulls. Foreign key, references another table's PK, nulls are allowed. Composite key, two or more columns, unique together, no nulls. Screenshot this slide, it is your exam cheat sheet. Top interview questions on keys. Question 1. Difference between primary key and unique key? Both are unique, but primary key cannot be null ever. A unique key can have one null. Also only one primary key per table, but multiple unique constraints are allowed. Question 2. Can a table have no primary key? Technically yes, but bad practice. Without PK, you can get duplicate rows, joins break, data integrity is lost. Real-world example, a bank database where all key types appear together. Customers table. Customer ID is primary key. Email is alternate key. Phone is another alternate key. Accounts table. Account number is primary key. Customer ID is a foreign key referencing customers. One customer can have many accounts, many to one. Transactions table. Transaction ID is primary key. Account number is foreign key referencing accounts. A 3-table chain, transactions to accounts to customers, all connected through primary and foreign keys. This is how every real-world database is designed. 6 golden rules you should never forget. 1. One table, one primary key. If 2 columns are needed, make a composite PK. 2. PK cannot ever be null. 3. FK can be null, means no relationship yet, and that is fine. 4. FK must reference a real PK. Inserting a FK value that does not exist in the parent equals database error. 5. Every table should have a PK. 6. With composite keys, watch out for second normal form. Every non-key column must depend on the whole key, not just part of it. Quick quiz. 5 questions. Question 1. Roll number and email, both unique and minimal. What are they? Candidate keys. Question 2. We pick roll number as PK. What does email become? Alternate key. Question 3. Marks table has roll number pointing to students. What type in marks? Foreign key. Question 4. Order items uses order ID plus product ID as the key. What type? Composite key. Question 5. Roll number, name, age can identify rows but is not minimal. What is it? Super key, not candidate key, it has extras. Drop your score in the comments. What is coming next in the database series? Diagrams, drawing table relationships visually. Normalization, 1NF, 2NF, 3NF, removing redundancy using our key knowledge. SQL joins, how you actually use foreign keys to query across tables. Indexing, how databases use primary keys to search fast. Transactions and ACID properties, keeping data safe. Subscribe so you do not miss any of these, and drop your questions in the comments below. And that is a wrap for today. 6 key types: super key, candidate key, primary key, alternate key, foreign key, and composite key. If you found this helpful, please like the video, share it with your classmates, and subscribe for more database and data science content. Drop any questions in the comments below. I read every single one. See you in the next video. Take care.